Hello children, welcome to Maths class. Hope you are all getting ready for Term 1 examination. On account of Term 1 examination, we are making our learning fast. Okay children, so that we will have enough time for revising all the 8 chapters. Before getting into today's session, here is something which I would like to share with you. See here, if we think of a world without maths, right from ancient times, if mathematicians have not worked on it, we would have not been able to attain this technology. Everywhere we use maths. See, Pythagoras ratios are being used in guitar frets. I believe many of you are having a very good knowledge in playing guitar. I want you all people to discuss these things with your music teacher and present a video. What does this Pythagoras ratio have to do with this guitar frets? So that those who are not aware of these things, they will learn. Okay children, I hope at least few will take steps to find what is behind this guitar in terms of maths. Okay children? Okay. And now we are discussing the chapter Understanding Quadrilaterals. We started with the polygons. The sum of interior angles of polygon with n sides is n minus 2 into 180. If it is a triangle, it is the total angle is 180 degree. And if it is a quadrilateral, the sum of all the angles in that quadrilateral is 360. And if it is a pentagon, it need not be regular, my dear children. Whatever may be the polygon, depending upon the number of sides, the total sum of all the angles, interior angle, keeps on varying based on the formula n minus 2 into 180. Then the next thing is, we discussed about exterior angles. It is independent of the number of sides. So every time the sum of interior angles of any polygon is always 360 degree. And if it is going to be a regular polygon, we can find the value of one angle by dividing 360 with the n. Hope you all remember these things. Then we learned what is trapezium. It's a quadrilateral with a pair of parallel sides. Then kite. It is a quadrilateral and two distinct consecutive pairs of sides are of equal length. Then parallelogram. And we discussed many problems based on this parallelogram. Finding angles, isn't it? Whose opposite sides are parallel. Here both the pairs should be parallel. In trapezium, it's enough one side is parallel. Can you relate this parallelogram with trapezium? If I ask you, is a parallelogram a trapezium? What will be your answer? Yes or no? Definitely it should be yes. Parallelogram is a trapezium. If I ask you the other way, is trapezium a parallelogram? No, it need not be. It may not be, may or may not be, depending upon the parallel condition of the other two sides. Okay, here trapezium will have only one pair to be parallel. I am asking, is trapezium a parallelogram? It can be a parallelogram only if the other pair is also parallel. So, every parallelogram is a trapezium, but every trapezium need not be a parallelogram. Is it clear, my dear children? Okay. So, we can say that all kinds of parallelogram like a rectangle, rhombus, square, everything is a trapezium with a special condition over trapezium. But all squares will not be trapezium. Is it clear? Squares will not be squares are trapezium, but all trapeziums need not be squares. We should know to understand this. Okay, we will discuss many things in this video now. Here properties of parallelogram, just a recall. Opposite sides are of equal length. Opposite angles, angle B, angle D, angle A and angle C are equal. Then adjacent angles in a parallelogram are supplementary. Like angle B plus C is 180, C plus D is 180, D plus A is also 180, A plus B is also 180 degree. If I sum them now, adjacent angles, it will be equal to 180 degree. The last one is the diagonals of parallelogram bisect each other. See, these two diagonals AC and BD meet at a point such that it divides the diagonals into two equal halves. OD is equal to OB, OA is equal to OC. Then we have to find angle C now. If AB is parallel to DC, is it a parallelogram? Can I make use of all the properties of this parallelogram here? No, it is not a parallelogram. If one pair alone is parallel, what name can I give for this shape? Yes, it is a trapezium. Our objective is now to find angle C. Do you have any idea to proceed, my dear children? I will give you a clue. You can make use of the angles that we learn in parallel lines with the transversal. I introduced two angles in previous session. Are you able to recall those angles? Yes, they are alternate angles and corresponding angles. Locate the transversal and try to find it. Are you able to do it? Yes, of course, children. I am going to extend this line AB and line DC, and BC will be the transversal. So this angle is equal to here, exterior angle of this quadrilateral. Will you all agree? So what will be angle C now? If I take this whole complete straight angle, if this is 120, the other part will be 60 degree. It is very simple, isn't it? But here I am going to state you another property. See here, angle B plus angle C, sum of adjacent angles of a parallelogram is 180 degree. Here you cannot use this property here. Why? It's not a parallelogram at all, my dear children. Okay. But they have used this property. Of course, we can use it in the sense, if I take these two adjacent angles alone. If I have this reason, hey, if sum of adjacent angles of a parallelogram is 180 degree, and if I take, what are the adjacent angles for B now? A is also adjacent, C is also adjacent. Here they mean the adjacent angles to be C only, my dear children. Do you understand why they took C and not A? If I take A, will it be right? No, we cannot take it. Because it is this side, the transversal is different. This transversal is different. So, we can consider the adjacent angles along the same transversal line and we can use this property. Okay. I just said the explanation in advance so that you should not ask me the doubt, ma'am, why you didn't consider angle A to be adjacent angle here. Hope you understood. Instead of having this property, you can better go in for alternate angles. Angle B and this angle BCX, something like lateral X, and say this is equal to 120 because alternate angles are equal. Then you can use the straight line property, straight angle property, find angle C. Is it clear, children? 120. This here we use straight angle property only. Okay. The next question here is, okay, we are going to talk about special kinds of parallelogram now. Okay. A rhombus. What is a rhombus? Yes, it's a parallelogram where all sides are equal. Of course, it looks like a square. The only thing is it is tilted a bit. Okay. So you are going to do this activity in your classwork note. Hope you remember you did an activity for kite. Taking a paper, folding it and making two line segments of different measurement. AB is of different length and CB is of different length. These two are of different measurement and you cut it and pasted it, and this makes the kite shape. Here also I am going to make a kite, but the difference is the measurement of both this line segments should be same. If AB is 4 cm, BC should also be 4 cm. Then we get a rhombus. Okay, we have all the four sides to be equal. So what is special about rhombus? So rhombus is a parallelogram. It satisfies all the conditions of a parallelogram. It accepts or it follows the properties of parallelogram and also kite. Okay, so it acts both like parallelogram as well as kite. Is all rhombus a kite? Yes. Is all kites a rhombus? No, it need not be. A kite will become a rhombus if all the four sides of the kite are equal. Is all parallelogram a rhombus? No. A parallelogram will become a rhombus if all sides are equal. Is all rhombus a parallelogram? Yes, all rhombus are parallelogram. All rhombus are kites. Children, you are going to have a test session now. So, take care of all these words. The next important thing to talk about here is the diagonals of this rhombus. I said it satisfies the properties of both parallelogram and kite. In parallelogram, what is the fourth property we learned? The diagonals will bisect each other. Isn't it? In kite, what about the property of this diagonal? Yes, the diagonal will intersect at 90 degree or perpendicular to each other. So, here we will use both the words. Perpendicular bisector. The diagonals of a rhombus are perpendicular bisector. It is also perpendicular and also bisects each other. See here, we will also have 90 degree and all these four measurements will be equal. That is, this diagonal and this diagonal cuts each other into equal halves. Okay, children. Now the special shape, a rectangle. Is rectangle a parallelogram? Yes, of course. Is every parallelogram a rectangle? No, need not be. Hope you understood how I asked these questions. A rectangle is a parallelogram with equal angles. And what is special about this angle? All the four angles are going to be 90 degree. A rectangle is a parallelogram in which every angle is a right angle. Now tell me about its diagonals. It's a parallelogram. So surely they will bisect each other. And what about their angles between them? Should it be 90 degree? No. Only in rhombus and kite, the diagonals intersect at 90 degree or the diagonals are perpendicular. In parallelogram, in rectangle, they will not be perpendicular, but they will bisect each other. Hope you understood what is bisection and what is perpendicular. Bisection in the sense, if we have O here, this OA measurement is equal to OC. OB measurement is equal to OD. That means the bisection. If it is perpendicular, the angle between these two lines should be 90 degree. Here in rectangle, it will not be perpendicular. Hope it is clear. The diagonals of rectangle are of equal length. Surely they will be of. What about in parallelogram? Will the diagonals will be equal in a parallelogram? Is it necessary for the diagonals to be of equal length? See here, this diagonal is smaller compared to this diagonal. In parallelogram, the diagonals will not be of equal length. But in rectangle, the diagonals will be of equal length. In rhombus also, the diagonals will be of equal length. And they will bisect each other. They are perpendicular. All these three conditions are satisfied in rhombus and not in parallelogram and rectangle. Hope you are able to compare the properties of these